Welcome to Mitchell Maths. In this video we're going to have a look at circle theorems. First we're going to break up this video into some sections and we're going to have a look at a few rules at a time and then have a look at some questions involving those rules. Because there are quite a lot of rules to remember. I think there's 9 in total for circle theorems. So the first three rules we're going to look at is angles in the same segment are equal. What that means is we'll have a shape which will look something like, a bit like this. And what it means is we've had two lines coming from these 2 points and they make an angle on the circumference of the circle. And these 2 angles will be equal because it doesn't matter. If the 2 lines come from these 2 points, wherever they form around the circle on this side, they're going to be the same angle. So this angle would be equal to that angle. And you could even do it the other way around if we look at, because we've got these 2 points and we've got 2 lines forming angles on this side. These 2 lines angles would be the same also. So that's what, that's what it means when angles in the same segment are equal. The other one, which is 2 radii form an isosceles triangle, it's actually quite obvious, but it is one that can quite easily be missed. So what we mean by 2 radii is if we have the centre of the circle and we have 2 lines going to the circumference, that'll obviously be the radius. And wherever the radius is on the circle, it's always going to be the same. So if we had a triangle like that, it would be isosceles, which is quite useful when working out angles because we know that this angle and this angle would be the same. And that would mean we'd only need one angle in order to work out the rest of the angles in the triangle. And the last one we're going to look at in this section is the angles in a semicircle is 90 degrees. This can be quite often identified because in the question you'll have 2 points and it'll tell you it's the diameter. I know that's a bit off, but you might have like point A, C, and they might say in the question AC is the diameter of the circle. And that means, it passes through the centre. And any angle it forms with the wall is 90 degrees. Could be this side or it could be the other side. So angles in a semicircle is 90 degrees. Again, it means you only have to know one of these angles in order to work out the other angle in the triangle. So that's angles in a semicircle, 2 radii form an isosceles triangle, and angles in the same segment are equal. So let's have a look at some questions. Find the value of x. So what we can see from looking at this is going to be sort of like a same segment question. We can see that this 24 is sort of like, this 24 here has been formed from 2 lines coming from these 2 points. And we can see that the 2 lines coming from these 2 points also form this angle here as well. So that angle there must also be 24. We can then add, because we know that angles in a triangle add to 180. So we can add 98 and 24, which will equal 122. And we can and then we do 180, take away 122, which gives us 58 degrees. So that would be angle X. So we'll have a look at this one. This one looks a little bit more complex. Well, what we've been doing is we've been given a centre here, and we need to find angle X. Now, what I can see that this triangle here is isosceles, which is important because if you see O is the centre, so these 2 lines must be the radius. I can also see, if I look at triangle DCB, the bigger triangle, DB, because it passes through the centre, must be the diameter. And that means it forms a semicircle. So I know that angle DCB, this angle here, must be 90 degrees. And if I know that's 90 degrees, I can just do 90 take away 55 to find this angle here. So I'll do 90 take away 55. That will be 35. Therefore, this angle here is 35 degrees. And because this is an isosceles triangle, this angle here will be different, and these two angles at the bottom will be the same. So that means that x in this question is 35 degrees. Now let's have a look at four more rules. A tangent and radius meet at 90 degrees. If you've got a radius from the centre of the circle and it meets a tangent, so a tangent is a line that just touches a circle and goes past, the angle that the radius and tangent make will be 90 degrees. The perpendicular bisector of a chord passes through the centre of the circle. A chord means a line that goes through 2 points on a circle, and if a line is perpendicular at 90 degrees and bisects it, goes through the middle of it, it must pass through the centre of the circle. The angle at the centre is twice the angle at the circumference. Quite often we get a shape that looks a bit like this. So we'll have a middle angle. And what you find is if you measure the angle at the centre and you measure the angle at the circumference, the angle at the centre is always double the angle at the circumference. So if this was x, the angle at the centre would be 2x. So that's quite important. So angle at the centre is double the angle at the circumference, doesn't matter how you arrange it. And finally, opposite angles in a cyclic quadrilateral. Cyclic quadrilateral means a four-sided shape where all 4 points are on the circle. And make sure all 4 points are on the circumference of the circle. Sometimes you can get quadrilaterals where one of the points is in the centre, and that's not cyclic. So do watch out for that. So a cyclic quadrilateral would look like something like this. Okay, obviously the lines would be straight, and if you have A and B, if the angles are opposite, then A plus B would equal 180. Or even it works the other way around, C and D, C plus D would equal 180. So do look for that. If you have a cyclic quadrilateral, the opposite angles in that will be equal. Sometimes it won't be just drawn as a four-sided shape. There might be lots of stuff going on in the middle of it. But if it forms 4 points on the circumference, then the opposite angles will add up to 180. Right, so let's have a look at some questions. This one, we're trying to find angle x. What I can notice from this when I look at A, D or B is I've got an angle in the centre. And if I've got an angle at the centre, I need to see, do I have an angle coming at the circumference, which follows the same shape I drew on the other last slide? Well, it does it it's like this angle here. And I know that A will be half of 166. So 166 divided by 2 is 83. So this angle here is 83. I can also see that A, B, C, D form a cyclic quadrilateral because A, B, C, D are all points on the circumference of the circle. And I know that opposite sides, opposite angles in a cyclic quadrilateral add up to 180. Therefore, 83 plus x must equal 180. Well, if I take away 83, I get x equals 97 degrees. Okay, so that's using the rule about cyclic quadrilaterals. An angle at the centre is double the angle at the circumference. Right, so this one's another a little bit different. We've got, now in the question it's told us that AB is a tangent. And we've got a triangle. We've got A or B. But at the moment we've only got one side, which is 49 degrees. However, from our radius tangent rule, because you can see that the OB comes from the centre. It's told us that O is at the centre of the circle. We know when a radius meets a tangent, it forms a 90-degree angle. Therefore, if we do 90 plus 49, that's 139. And then we can do 180, take away 139, which will equal 41 degrees. So therefore, this angle here is 41. We can see that A to C is a straight line. Therefore, angles on a straight line add up to 180. So it'd be sort of like 180 take away 41, which would just be 139. So that would be, 139. And the other, we've got triangle OBC, which so far we've only got one angle for. But because O is at the centre of the circle, we know that OC and OB are both radiuses. And if we think back to the one before that, we know that if they're both radiuses, that both sides are the same length. Therefore, what we've got is an isosceles triangle. What I need to do is I need to do 180 take away 139, which will be 41, as we've already done it up there. And I know that these two angles here will be the same, therefore it'll be 41 divided by 2, which will be 20.5 degrees. So x is 20.5 degrees. So that uses radius, when a radius meets a tangent, it is 90 degrees, and it also uses two radii, form an isosceles triangle rule. And now we're going to have a look at our two final rules. Tangents from the same point are the same length. What that means is if we've got a mark outside the circle, and we've got a tangent coming to it, and then we've got another tangent coming from another point on a circle, we know that those two tangents are going to be the same length. So if this was A and this was C and this was B, we'd know that AC is equal to AB. Now quite often what we'll get is we'll get points, we'll see this shape here where they meet the centre. And because if that's a centre, then these 2 points will form radiuses. And that forms like a sort of like a quadrilateral type shape. If we know one of the other angles, like for example this angle here, we can work out this angle here. Sometimes we'll need to sort of split this shape in half, and if you have a line coming from the centre, that sort of bisects this angle here, so each side, if this angle was x, each side would be 0.5x if it was split in half. So there's a few things you can do with that shape, as we'll have a look at one of the questions in the next couple of slides. We've also got alternate segment theorem, and what that is when you've got a tangent hitting a circle, and you've got a triangle from that tangent. This angle here is equal to the angle in the opposite segment. So if we look at the opposite segment, the angle that's opposite in the triangle, we've got, so this angle forms with this side here, doesn't it? So if we look at this angle that's opposite this side that forms this angle with a tangent, we can see it's here. So that angle will be the same as that angle. It also works on the other side too, so we've got angle Y here, and that forms along this segment, along this line here forms the angle Y with this line, with a tangent. And we can see the angle opposite to this line is here. So that will be those two angles will be the same. So that's alternate segment theorem, when you've got a triangle which meets a tangent. Right, so this one we've got a tangent, we've got a couple of triangles. That probably tells us that it's going to be alternate segment theorem. First of all, we want to find x, which is here. And to do that, we're going to need to find this angle here. But what I can see is that I've got 50 degrees here, and if I look at this triangle here, Well, this line here forms the angle 50 degrees with the tangent. And if I look at the angle that's opposite that, it will be this one. So that means that this will be 50 degrees. And now I've just got angles in a triangle add up to 180. So if I do 50 plus 43, that will give me 93. And then I'll do 180, take away 93, which will be 87 degrees. Therefore, X is 87 degrees. So that's an alternate segment theory question. Right, this is where tangents come from the same point to the same length, or that sort of question. We've got that sort of shape. And it wants us to find angle A or B. Well, we haven't actually got side AO on the diagram yet. So let's draw it in. So we're going from O, and we're going to draw to A. So the angle we're trying to find is this angle here. And we can see when we draw the line AO, it makes a triangle AOB. Because this is O is the centre, we know OB is the radius of the circle, and we know when a radius meets a tangent that the angle is 90 degrees. Also, this line that comes from the centre of the circle and to A also splits this angle in half. 30 divided by 2 would be 15 degrees. Therefore, we know that this is 15 degrees. Because we've got 15 degrees, 90 degrees, we can work out our missing angle. 15 plus 90 is 105. And then we can do it 180, take away 105, which will give us 75 degrees. So that's the sort of type of question you could get when you've got two tangents coming from the same point. You might need to work with that sort of shape. Right, thank you for watching. I hope you found it helpful. If you liked the video and like to see more, please hit the subscribe button. For practice questions, please visit my website, www.mitchellmathsandscience.com. The link is in the description.